Hi guys, I'm just going to run a brief lesson on graphing logarithmic functions. So just a quick recap. We know that this is an equation in index form, y equals a to the power of x. When I say a logarithm, we're doing the opposite of this. So rather than y being the subject, x is now the subject. Then I go log y to the base a. Now we could see some very clear key features here. A is always the base. The subject was y, now it's x. So logarithms are the inverse, or the opposite, of exponential functions. Okay, so how do we graph them? It's very easy. So we recall that the basic shape of a exponential function, I will do that in red, was this, where the asymptote is that. So since log is the inverse, if we remember, we reflected across this line here, y equals x. So in blue, a logarithmic function looks like that. We could see that they're just mirror images. Okay, and this time the asymptote is at x equals 0. So the asymptote is at x equals 0. Alright, cool. Let's zoom out. Alright, so basic equation, y equals log x to the base a, and the shape, we said, looks like that, and that's our asymptote. Okay, that's our basic shape. So for example, I could have this equation, y equals log x to the base 2. Okay, if I ask you to graph that, you would draw your axis there, y, x, you would put your asymptote, and you would actually say asymptote at x equals 0. You would put the basic shape, and then you would go on to find that x-intercept. We know there's no y-intercept. We'll just fix up to g, so it's clear that that's a log. We know that there is no y-intercept because x equals 0, or the y-axis, is the asymptote. So how do we find the x-intercept? We let y equal 0, so 0 equals log x to the base 2. Turn it into index form, so it becomes 2 to the power of 0 equals x. So we know that anything to the power of 0 is 1, so therefore x equals 1. So our intercept is 1, 0. Very easy. Okay. Now let's go through the reflections as we've done in our previous video with exponential functions. I'll keep that in the corner. So if I have y equals log base a negative x compared to y equals negative log x to the base a. Okay, if in the first example, because the negative is in front of the x, we're going to reflect it in the y-axis. So I get a graph that looks like this. Well, actually, I might actually draw that one more time, because it doesn't look as clear as I want it to. Should look something like that. Okay, so we could see that it's the inverse, sorry, not the inverse, sorry, it's reflected about the y-axis. So this is how it originally was, I'm going to reflect it, so it's going to look like that, which is that shape here. So again, it was originally like this, again, in that shape, now the y-axis becomes my mirror. If it's negative log x to the base a, then the reflection is in the x-axis, so the graph still has the asymptote there. Put it in blue, and the graph just looks like that. So the x-axis is now the mirror. Nice and easy. Okay, what about our translations? So for example, if I have y equals log x minus 2 to the base 2, for example, the x minus 2 means, and we've seen this before in quadratic functions as well, cubic functions, etc. When there's an x minus 2, it means I move the graph 2 spots to the right because it's a negative 2. The best way I like to remember is if I go, oh yeah, x minus 2 equals 0, so x equals 2. So I'm moving it 2 spots to the right, and the asymptote becomes at 2. So because I've moved it 2 spots to the right, the asymptote moves from x equals 0 to x equals 2. And the same shape of the graph, because there's no reflections. Now I have to find the x-intercept, so that y equals 0, so 0 equals log x minus 2 to the base 2, let's accept that 2 there. Okay, turn it into index form, 2 to the power of 0 equals x minus 2. We know that 2 to the power of 0 is 1, so therefore x equals 3. So that's 3 comma 0 is that intercept there. Okay. Now the last one I'll show you. Say I had y equals log x to the base 2 and then a plus 3 at the end. So it's not in the log there. The only thing that's being, oh that looks bad. The only thing that's here is the x. That's better? Slightly. Okay. So let's draw the axis again. X, y. Asymptote is still x equals 0. Why? Because the translation that we're doing is up or down, because it's the plus 3 is here. It's not in the brackets with the log. Previously, the brackets were with the log or in the log, so we actually translated it 2 units to the right. See the difference? X minus 2 in brackets, x in brackets, and then a plus 3. So this time what we're going to do is we're going to translate the graph up. The asymptote doesn't change, because if you just translate it up, it's still a straight line. The asymptote is still there. The graph just looks a little bit taller. Let's find the x-intercept, y equals 0, so 0 equals log x to the base 2, plus 3, take the 3 to the other side, negative 3 equals log x to the base 2, turn that into index form, 2 to the negative 3 equals x, 2 to the power of negative 3, I'll just have to zoom, 2 to the power of negative 3 is the same as 1 over 2 to the power of 3. 2 to the power of 3 is 8, so 1 over 8 equals x. So that means I could say that the intercept is at 1 over 8 comma 0. Alright, thanks guys.